Hello, welcome to 9-3. We are talking logarithmic functions, and we are going to graph today. Everyone's favorite thing, graphing. We'll also state the key features too after the fact that we have graphed. So let's go ahead. Let's check out some logarithmic functions. Whoop. And look at some of the key features that logarithmic functions share. So here, a logarithmic function of the form f of x equals log base b of x minus h plus k has, in general, the following key features. It will have a vertical asymptote at x equals h. So if we have a translation, the asymptote will be at that h value. The domain will always be greater than h, and then the range, again, the y values, right, will be from negative infinity to positive infinity. So let's check out some key parent functions that we'll use for logarithms. And the first one we're going to check out is base 2. Now, what I want you to notice is, again, that we have an asymptote at x equals 0. Okay, so here's our asymptote. And we have a 0 at 1. So all the functions that we'll be looking at will have these values. Now, the second point that we'll use, okay, will always be what that base is. Okay, so log base 2. So at 2, I'll go over, and then my next point will be 1. So whatever that base is, that's our next point. Okay. The other points are derived again from the inverse of the exponential function 2 to the power of x. Okay. So here, just some of our key features. We'll note, right, the function is increasing. It's constantly going up. We will talk about end behaviors, what happens. So we'll recap what the end behavior is. And yeah, okay, so let's go ahead and look at base 10. So again, here's base 10. Note, again, we have the asymptote at x equals 0 and a 0 at 1. So here's our 0, and then notice how the next point, right, it's base 10, so I have to go over 10 values before I get my first point at 1. Okay, this function's also increasing. Okay, and then the last parent function that we'll introduce is the base e function. So here is base e, the natural log of x, and the natural log of x, again, has the asymptote at x equals 0. So I have an asymptote, and I have an anchor point at 1. So here is my 0. And then the next point, right, it's natural log, so I have to go over e, approximately 2.718, and then I get my first point at 1. Second point is e squared, and I go up 2. Okay? So these are some of our parent functions that we'll be utilizing and that we will be graphing today. Okay, so let's go ahead and get to it. Let's graph. So what approach do we use? We'll know the graph of the parent function. So it's very, very important to note. You have to look at your function and say, okay, what type of function am I graphing? Okay, so that's very important. Second, we'll transform the vertical asymptote, and again, this is affected by our movements left and right. Okay, and then step 3, we'll transform the key points. Okay, so here is our first example, and we have g of x is equal to negative 3 log of x plus 2. Okay, and what we're going to do is I'm going to start out by plotting the parent function. So what I'm going to do, I'll place my axes first. Okay, and I'm going to go ahead and plot the parent function f of x. So this, note that this is base 10, right? This is a common log, base 10. So I'm going to go ahead and I'm going to have, again, an asymptote. Okay, my first point, my 0, will be at 1, 0, and I'll have to go over 10 before I go up 1. So over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is f of x. Oh, that's terrible. Can't have that. Okay, so this is f of x. All right, so what we're going to do is identify our transformations. Note we have an a value that is -3, and I have a k value that is 2. So I'm going to always do my stretch and compression first. Okay, so note stretch and compression isn't affected by points on your x-axis. So my anchor point here isn't affected, right? I'm not going to stretch that by a factor of -3. But then I'm going to go ahead and move it up 2. So up 1, 2. So there's that point. Okay. And then my next point here, so over 10 up 1, I'm going to stretch it by a factor of -3. Okay, so that's my next point. So I have, okay, this point here. So a factor of -3, okay, the negative causes reflection. So I'm going to reflect down, and I'm going to go down 1, 2, 3, but then I'm also going to move up 2. So I did my reflection by a factor of 3. So instead of going up 1 and then I go down, and instead of going down 1, I go down 3. So down 1, 2, 3. But then I have my k value, which is 2. So I have to shift up 2. So up 1, 2. So then there is my next point. Okay, and here is our function. So grab this function. Ah, it's terrible. Okay, so here is g of x. All right. Okay, so let's go ahead and talk about the key features. The key features domain. Notice that the domain is just greater than our asymptote, which is at 0. So we have an asymptote at x equals 0. Okay, our domain is x such that x is greater than 0, which would be 0 to infinity. Our range, again, is always going to be all real numbers. So the y values such that -infinity is less than y, which is less than infinity. So we go from -infinity to positive infinity. Our 0 in this case is approximately right here. So our 0 is 4.642. Our y-intercept, we have none. Okay, and then end behavior. So end behavior, as x approaches 0 from the right, g of x is going up to positive infinity. On the right side, as x approaches positive infinity, g of x is approaching negative infinity. Okay, it's going down. It's going to keep decreasing. Okay, and this is a decreasing function. All right, so note on the 0, how you're going to get that is you're going to plug it into Desmos. Okay, zeros can be complicated, especially when we're sketching here. So sometimes they're easy. On these cases, this one you had to have some graphing software to help you find that. Okay. All right. Here is the next example, and we're good on time. Here's what I'm gonna do. I'm gonna give you guys a practice problem. So here's a log base 10. Please go ahead, try this one, and then I will post the solutions after you try this. Okay, so hopefully you've had time to go ahead and give this a go. Here is the solution. All right, I'm gonna stop the video here. I will come back. I'll post a second video on graphing natural log. Okay, catch you next time. Peace.